Hi, we're looking at triangle similarity today, and we're creating flowcharts for that. So it's just a new way to organize your thoughts when we're looking at why triangles are similar. So we're looking at these sets of triangles here. We want to know if they're similar. Remember the three ways to prove triangles are similar. We can have three sets of sides that all divide and give the same ratios, side, side, side. We can have side, angle, side, two sets of sides with an angle in between. And we can have angle, angle, side similarity. I'm sorry, angle, angle similarity, rather, just two angles. Okay. So we're looking at, are these triangles here at the right similar? And we're going to kind of explain our reasoning here. So I'm going to mark angle B, which is 75, and it's equal to angle P. So we could say angle B is equal to angle P, and they are both 75. We also know that angle, let's call this angle A and angle T, those are both 32. Angle A is equal to angle T, and they are both 32. So now we have two sets of angles that are equal. So we could say, therefore, the triangles are similar. Therefore, the triangles are similar because of we'll say by angle, angle similarity. So if we have two angles that are the same, the triangles will maintain the same shape because those third angles would also be the same. Now what we're looking at is a different way to essentially format this. So we have a flow chart. Okay, so we're looking at pieces of given information here. Okay, so we're looking at this flow chart here. It is a different way to kind of organize our thoughts and our information. So you can notice here we have angle A equal to angle T. So that is in our statement here, in our sentence format, what we wrote out. Okay, we know they're both 32, and that's given information. So the fact that they're 32 degrees each was just on the diagram. We didn't have to do anything to solve for that. Our other piece of information here is angle B and P. Okay, they are both 75. They're equal to each other. That's given information. And then you can see here this flow chart has arrows pointing to what that proves. So if we have two angles that are the same, that proves the triangles are similar. And the reason that they're similar is because of this angle, angle. Okay. So we want to know, did Julio use the same reasoning? So our flowchart uses ovals connected by arrows to show the logical structure of an argument. Okay, each oval has a reason stated next to it showing how the evidence leads to that conclusion. So yes, the evidence was the same in a different format. So now what we can do, this is similar to what you were working with in our similar triangle in a Desmos here, where we collected pieces of information, and then based on that collected information, we were able to figure out why triangles were similar. So now we're just going to put this into like a formalized, we call it a proof. Okay. So we're creating a flowchart here, and in our flowchart, we have a side length here 20. That is matching or corresponding to this side length here of 32. And we're going to put those into a ratio format, so 20 over 32. And that's going to simplify to 5/8. You can put this in a Desmos calculator. We can put this into calculators in the classroom. Now, those numbers were on the diagram. We didn't do anything to solve for them, so that's given information. Okay. And then we have some angles that are equal. Let's see what we identified as the first one. TJK. TJK, that's this angle here. If I were to trace from T to J to K, okay, that's TJK. Now that angle, if I take that angle and kind of slide it down the transversal, it's going to land here. We call those angles corresponding, and we know they're congruent when we have parallel lines connected by a transversal here. So those angles are corresponding. So we can say angle SKL, and we'll say corresponding, and we marked it on our diagram. So when parallel lines are equal, corresponding angles are congruent. And then the last side we would need to kind of compare here is these matching sides. We've got the 14 matching up with the 22.4. So let's see what that simplifies to, 14 and 22.4. And that's also 5/8. So it simplifies to 5/8. Now for all of the side lengths on a diagram, they're always going to be numbers that are placed there, so that's always going to be given information. So if you notice here, we have a proportional side statement, we have a congruent angle statement, and we have another proportional side statement. So these triangles, remember we had the 3 ways to prove triangles are similar. They are similar because of that side angle side reason. So I can now say triangle TJK is similar to triangle SKL, and that's because of side angle side similarity. Okay. All right, now we're going to look back and we're going to look at creating some flowcharts from one of the last lessons. So examples kind of each. So these were problems that you saw in the lesson previous. So here's an example from this one here. Now we already answered that question, but now we're going to put it into a flowchart format. Okay. So in our diagram here, we need to prove that there's some angles that are the same. Well, anytime you see those arrows, those are parallel lines. These 2 lines are parallel. And when lines are parallel, we can connect them with a transversal, and I can actually connect them with either one of those transversals. And I'm going to mark the angles inside here congruent. And that's actually corresponding angles, just like our last diagram. This angle here would kind of translate or slide down the transversal to this angle here. So I'm going to call that angle NMQ or NML, either one, and as long as M is in the middle, MNL, and we can say that that's congruent to PQL. And the reason they're congruent is because they're corresponding. And when you have parallel lines, your corresponding angles are congruent to each other. Okay. Then you could either do the other set of corresponding angles, or we can look at these angles here down at the bottom in both triangles. So here's one triangle. It has angle L. Here's my other triangle. It also has angle L. So we could say that angle L is congruent to itself, angle L. And if you want, you can put a little mark in the angle symbol so we know it's angle. And that's a reflexive property, when any angle is congruent to itself. So we call it reflexive, we can call it the same angle. Now we have 2 angles that are the same. So we have this triangle here, triangle QPL, and it is similar to this overall larger triangle. So if I started with Q, then went to PL, I would do MNL. And the reason that they're congruent, or similar rather, is because of the 2 angles that are the same angle. So you notice every box has kind of a statement in it, and every box underneath it has a reason for that statement. Okay, let's look at an example that we looked at previously. Here we have a side-side-side similarity. So remember, we always pick I always like to start with my 2 smallest sides. So that'd be 8 and 14.4. We can put those over each other in a ratio, and let's see what that simplifies to. I'm going to pick the middle sides in terms of length, 15 and 27. And then we're going to pick the 2 longest sides, and that's going to be 17 and 30.6. Okay, so now we just need to check, do these ratios actually simplify to the same value? So we've got 8 and 14.4. Move myself up there a little bit. Be clear all. So 8 divided by 14.4. Let's check we have 2 other ratios. 15 and 27. And our last ratio was 17 and 30.6. So they all equal 0.5 repeating. It's also okay if you want to write them in reverse. That would have been fine. But if I'm doing the smaller over big, I would keep that consistent. So I could say, and you could set them equal to a decimal. That's fine. So this is 0.5 repeating. That works. This is 0.5 repeating. And then our last one is also at 0.5 repeating. Okay, these are all given information. Anytime you have numbers on a diagram, you didn't do any solving to figure those out. They were already there. This is a side proportionality statement. This is a side proportionality statement and a side. We have three sets of sides that are proportional and they all equal the same proportion. These triangles are therefore similar. So I'm going to start with triangle and let's do yx, and then z. And let's say that's similar to. So if I started with y is between the blue and purple side. I'm going to start with w, between the same sides. And then let's go to x next. I'm going to put 2 marks on x. So I went down the purple side. That would match up with v. And then our last angle would have to be the r. Now these are similar because we had 3 sets of sides that were proportional. That's a side, side, side. Okay, we'll do one more together. We have here side, angle, side. This was from an example problem that we did previously. I would compare, let's compare the smallest sides in the diagrams. So 6 is the smallest side in this triangle, 24 is the smallest side. And this time, let's maybe do the big triangle measurement over the smaller. Doesn't matter, but we'll do that. And 24 divided by 6, that's 4. Okay, and then we can do our other side statement. I'm just going to put it over here. That would be a 48 and a 12 in comparison. So 48 divided by 12, well, that is also 4. These are both given information. They were on the diagram. Now, there is one other thing on the diagrams that are equal to each other, and it would be these angles here in the middle. We call those vertical angles. So we can say angle FEG is similar to angle, if I started with F, I'll do RES. Just need one more E for my name. Okay, so we've got here vertical angles. Now, this is a side proportionality statement. This is an angle statement, and this is a side proportionality statement. These triangles are therefore similar, and I'm just going to turn my angle statement into a, and I should put congruent here rather, into a similarity triangle statement, RES, and that's because of side, angle, side similarity. Okay. So now you're just going to be working through the rest of these flowcharts, proving if these triangles are similar all the way through this page here.